Hello all, welcome to the second session of the fundamental series. In this episode, we are going to talk about a very important topic, which is cross multiplication, right? What is cross multiplication and how do we leverage it, especially in the context of fractions? And more importantly, when we cannot use cross multiplication, right? So we know that we have heard about this term uh, very often, but I seen that there is a lot of unclarity in terms of when we can use and when we cannot use, right? So let's get started. Okay. So the first and the foremost thing for us to be able to use cross multiplication is that there has to be an equation, right? There has to be a left side, right? And there has to be a right side. Okay. Now, the left side has to be a single fraction, okay? And the right side also has to be a single fraction. No matter how small or big the fraction is, that does not matter, but each of these sides have to have a single fraction. Only then we can use cross multiplication. Let's see what we mean by that. So let's say we have this question 1 plus 2 over x is equal to 4 over 5, right? And we have to find the value of x, right? So the first thing, right, we do have an equation, we have a left side, we have a right side. Can we use cross multiplication, however? No, because the right side is a single fraction, 4 over 5 is a single fraction, but the left side is not a single fraction, it is 1 plus 2 over x, right? So 2 over x is a fraction in itself, and 1, like 1 over 1, can also be considered as a fraction. So essentially, right, we have got two fractions on the left side, right? So at this point of time, if we have to solve for x, we cannot do cross multiplication, but we can do something to make a single fraction on each of the sides, right? So what we're going to do, we're going to bring 1 onto the left side, onto the right side, right? So we're going to do -1 here and -1 here. So the left side becomes 2 over x because 1 minus 1 gets away. And on the right side, we have 4 over 5 minus 1, which is equal to 4 minus 5 over 5 or minus 1 over 5, right? So essentially, we have 2 over x is equal to minus 1 over 5, right? At this point of time, we have a single fraction on the left and a single fraction on the right, and hence we can do cross multiplication. What happens in the cross multiplication? These two terms get multiplied and they come on one side of the equation, and these two terms get multiplied and they get onto the other side of the equation. So essentially we get 2 times 5 is equal to minus 1 times x, which is minus x, or 10 is equal to minus x, right? Or in other words, x is equal to minus 10. Okay. So just to revise this very quickly, we had the question 1 plus 2 over x is equal to 4 over 5, right? At that point of time, we cannot do cross multiplication because on the left side we had two fractions. So we moved 1 to the right side, we did -1 here and -1 here, which gave us 2 over x is equal to -1 over 5. Now we have a single fraction on each of the sides. We did cross multiplication and found the value of x. Okay, let's go ahead with another question. Right, so we have minus 3x minus 1 divided by 2x minus 5 is equal to minus 14 over 3, right? Okay, so again, on the left side we have a single fraction, even though it has many negative signs or whatever, it doesn't matter, it's a single fraction on the left side, and on the right side also it's a single fraction. So basically we have a single fraction on each of the sides of the equation, and hence to begin with we can do the cross multiplication, right? So when we do cross multiplication, as we mentioned earlier, this term is going to be multiplied by this term. So minus 3x minus 1 will be multiplied with 3 equal to this term will be multiplied by minus 14. So 2x minus 5 times minus 14, right? These two terms get multiplied equal to these two terms get multiplied, right? That's what the cross multiplication is. Now let's expand them. So we get minus 9x minus 3 is equal to minus 28x plus 70, right? We bring all the x terms on one side and all the numbers on the other side. So we're going to bring minus 28x this side and minus 3 to the other side. So we do plus 28x here, and hence we do plus 28x here. right? 28x and 28x gets cancelled out. 28x minus 9x is 19x, minus 3 is equal to 70. We got to bring 3 to the other side, so we do plus 3 here and we do plus 3 here. 3 gets cancelled out. We have 19x is equal to 73. Finally, we divide by 19 on both the sides and we get x is equal to 73 over 19. Right? So this is how cross multiplication makes life so simple, right? A complex looking fraction like this gets reduced to a normal looking single variable fraction. Obviously this is also single variable, but it looks very complex and messy. But with the cross multiplication, things look so simple. Finally we get x is equal to 73 over 19. Okay, let's look at another question. 2x minus 1 divided by 3 minus x minus 2 divided by 4 is equal to 1, right? Okay, so do we have the prerequisites which we need for cross multiplication? Let's see. So on the right side we have 1. 1 is nothing but, let's say, 1 over 1, right? So we do have a single fraction on the right side, but we do not have single fractions. We have two fractions. We have the subtraction of two fractions on the left side. So we cannot do cross multiplication at this point of time. Okay. So what we're going to do, we're going to combine these two fractions, just like the normal subtraction of fractions, right? So we can multiply the first fraction by 4 and 4 and the second one by 3 and 3, right? Because we need to have the same denominator to subtract the fractions, right? Okay, so we get 4 times 2x minus 1 divided by 12 minus 3x minus 6 divided by 12 is equal to 1, right? We multiplied 4 with 2x minus 1 and we multiplied 3 with x minus 2 because we need to have 12, the same denominator on both the fractions. And now we expand this one, so we get 8x minus 4. So this becomes 8x minus 4, this is 3x minus 6. Okay, now we can subtract the fractions because they have the same denominator. 8x minus 4 minus 3x plus 6, right? We have to take care of the signs, is equal to 1. 8x minus 3x is 5x and minus 4 plus 6 is 2. So it's 5x plus 2. Right? Now at this point of time, we have a single fraction on the left and a single fraction on the right. Hence we can do cross multiplication, which will give us 5x plus 2 times 1, which is 5x plus 2, is equal to 12 times 1 is 12. We bring 2 to the other side, so minus 2, we get 5x is equal to 10. We divide by 5 on both sides to get x is equal to 2. So the solution of our original equation would be x is equal to 2. Let's quickly take one more example. Okay, so we have x over 2 minus 2 is equal to 4 plus 1 over 4, right? Clearly we do not have a single fraction on the left side, don't have a single fraction on the right side, so we cannot do cross multiplication, right? But we do notice that we have all these numbers here and we have minus 2 here, so we're going to bring minus 2 also to the right side. So we do plus 2 here and we do plus 2 here. So we get x over 2 on the left side because 2 minus 2 gets cancelled out, is equal to 4 plus 1 over 4 plus 2, right? Now these are all fractions, right? 4 is 4 over 1, 2 is 2 over 1. So we know how to add the fractions, right? So the common denominator would be 4, and this term will become 4 times 4, which is 16. This term will be 1, and this term will be 8. Finally we get 25 over 4, right? So x over 2 is equal to 25 over 4, correct? Now we have the single fraction on the left, single on the right, we can do cross multiplication. So we get 4x is equal to 25 times 2, which is 50. or x is equal to 25/2, right? Hopefully you guys got a good idea in terms of what is cross multiplication and how do we leverage it, especially in the context of fractions. If you have any questions, please do feel free to reach out to us at info.mathletes@gmail.com. See you in the next session.